Hi everyone, in today's video we will compare Polars and Pandas Python libraries. If you're just starting learning Python, this video will be beneficial for you because I will go into details how to open file, how to filter data, sort data, etc. So keep watching. And if you're an experienced Pandas user but haven't tried Polars yet, then this video is also for you. If you're new to this channel, I'm Karina, I'm a finance person, turned data analyst, turned data scientist, and now I share my knowledge with other people online. Several months ago, my TikTok followers started asking me what is my opinion about Polars library, and to be honest, I've never used this before, so I had to go and do my own research. Let's briefly talk about Pandas library. Pandas is used with tabular data, like Excel spreadsheets, for data manipulation and analysis. Python processing ecosystem is great for smaller datasets, but it is challenging to scale up when the dataset grows. Parallel processing, query optimization, and lazy evaluation are things are unheard of in Pandas library. Polars library was built with performance in mind. Polars library has a multi-threaded query engine written in Rust, which means you can expect very fast processing of your queries, probably 30-50 times faster than it is in Pandas library. Pandas has a single-threaded nature, and since our datasets getting bigger and bigger in sizes every day, so leveraging only one CPU doesn't sound that efficient and reasonable. That's why parallel and distributed processing is the future, and Polars can do that. And another thing about Pandas, Pandas require you to store the whole dataset in memory, which again is good if you have a small dataset, but is problematic when you have a massive dataset. So from my research, what I found about Polars, first of all, it can offer you parallel computing, so you can utilize all available CPU cores on your machine. Second thing is query optimization. It drastically reduces memory allocation by using query planning and lazy evaluation. Another thing is file scanning. It allows you to work with huge files by only reading the scheme of these files and not storing the entire dataset in a memory. And another thing is improved copy on write. Polars uses Apache Arrow to improve storage performance. Now let's compare Polars and Pandas. First of all, we need to install our libraries. To install libraries in Python, we do ! pip install and then names of our libraries. First we will install Polars, and in square brackets we say all, so all the version of Polars, space, and then Pandas as well. So you can install several libraries in the same line. It says that requirements are already satisfied because I have these libraries installed. The next thing we need to do, we need to import our libraries. So I will import pandas spd. Spd is alias we use for pandas library. It is a best practice to call pandas pd, and for Polars people use pl. So we'll say import pandas spd and import Polars spl. Let's run it. The next step, we need to read file. I will read coffee shop sales, the file I used in one of my previous videos. We will create two data frames. One will be pandas data frame, one will be Polars. For pandas data frame, we say df_pd, so we know that it is pandas, equals pd or pandas library dot read_excel. Brackets, in the brackets in quotes, you need to indicate the path to your file. This is how you read files in Pandas, and in Polars you use exactly the same syntax, but we need to say Polars or pl dot read excel brackets, and then we indicate the path to our file. I will put it into different lines of code, and let's run Pandas first. I will put how many seconds it took. Let's run Polars. Especially if you work with big file, you will see the huge difference between performance of these two libraries. Polars are very quick. Okay, now we have two data frames. One is Polars data frame, one is Pandas. So let's compare .head and .describe. First we will do .head in Pandas. So df_pd or name of our data frame .head brackets. This way you can display 5 top rows of your dataset. So you can see how your file looks like. This is the result, and now we will do the same but for Polars. It will be name of our data frame or df_pl.head brackets, and let's run that. Okay. Now you can see the difference. So with our pandas library, first of all, we have indexing. On the left, we can see index. In Python, indexing always starts from 0. So the very first element is element 0. In Polars, we don't have indexing. Another thing you can notice with Polars, it shows us shape. So it says that we have 5 rows and 11 columns. So to get that with pandas, we need to run .shape. Polars already show you the shape. Also, Polars gives us details about data types. Transaction ID is integer, transaction date a string, store location string. Again, to get this information with pandas, we need to run .info, while Polars already showed it to you. Another little thing that you can notice, that all the strings are in quotes. So you can see that integers are without quotes and all the strings are with quotes, which is different from pandas library. Let's do the same with .describe. So at first we do def_pd.describe brackets. Let's run it. That's how our pandas describe looks like. So we have columns and we can see how many rows it has, what the average value in that row, minimum 25, quantile 50, 75th, maximum number and standard deviation. And let's do the same with Polars. So def_pl, name of our Polars data frame .describe brackets. Let's run it. So you can see it's different. Again, we have shape, it says 9 rows, 12 columns. On the left, it's quite similar to what we had, so count, mean. It already shows us if we have any null values. So usually when you analyze data using pandas, we use isNull to check if there are any null missing values. In this case, it already shows us a count of missing values. Then again, mean, standard deviation, quantiles. Again, it shows if it's integer or string. What I like, so usually strings are not shown in .describe, but in this case, they are there. For example, with store location, we can see how many rows it has. And for minimum and maximum, of course, it is a string, so we can't have minimum and maximum integer value. Based on what I see, it shows Astoria as the first value is minimum. So I assume it's sorted values in alphabetical order from A to Z. So it shows that minimum value is Astoria and maximum is Lower Manhattan. Polars introduces you to the concepts of expressions to help you work with your data. There are 4 main expressions you need to understand when working with data in Polars. The first one is select, when you choose a subset of columns. The next one is filter, and this is when you choose a subset of rows. Next one is with columns, when you want to create a new column, and group by to group data together. Choosing or reordering columns in Polars is very straightforward, and we use for that select. For example, we want to select 3 columns from our existing dataset. We want to select transaction ID, transaction quantity, and unit price. Let's do that with pandas. To do that with pandas, we say name of our data frame df_pd, square brackets, then in square brackets you indicate a list of the columns you want to choose. A list in Python is always surrounded by square brackets. That's why we have double square brackets in this case. We indicate the list of all the columns, transaction ID, transaction quantity, unit price. Let's run it. Here we are, we have our 3 columns, we have all the rows. On the left you can see indexing of each row, and you see here we basically have our shape. It says how many rows we have and how many columns. And let's redo the same syntax but with Polars. So it will be name of our data frame df_pl dot select, then ordinary brackets, not square brackets. In the brackets we say pl.call for columns, again ordinary brackets, and then we indicate the columns we want. And let's run it. And the same here on top we have our shape. It says how many rows, how many columns, names of our columns, then it says the data type, which is integer, and the values. So you can see that we used pl.column. This is used to create column expressions. You will want to use it any time you want to specify 1 or more columns for an action. I think there is a shortcut to avoid using it, but it is best practice and it's recommended way to use this pl.call brackets. The next thing we will do, we will filter our dataset. So filtering is similar process to selecting, and we will again use pl.column. At first, let's filter our pandas dataset. So we say df_pd, and then I need to indicate my filtering condition. So I want to filter column unit price where the value is more than 3. I say name of my data frame, which is df_pd square bracket, and in those square brackets we indicate the condition, and condition is column unit price, so we say name of our data frame, again square brackets, name of the column unit price more than 3. Let's run it. Again, at the bottom you see the shape, number of rows and columns, we get all our columns, and if we check unit price you can see that all the values are greater than 3. And let's do exactly the same with polars. So it will be name of our data frame df_pl.filter, because we are filtering our rows, brackets, pl.column, brackets, and then we say unit_price or name of our column. You can see that in this case we don't need to indicate here name of our data frame like we've done in this case, but we say pl.column and then name of the column. Let's run it. And it proves that our shape is exactly the same, number of rows, number of columns, and you can see unit price, all the prices more than 3. I think those two things, select and filtering, was quite similar to Pandas, so it's very easy to get your head around. But for example, adding columns where we will start using with_columns might get a bit trickier, or I would say it will just take you a little bit of time to get used to this expression. So the easiest way to think about with columns, that every time you want to add a new column, you have to use with_column. In our dataset we have transaction date. What if we create a new column that says what month it is? Is it a January, is it a February, etc. To do that with Pandas, first of all, we need to convert our datetime from string to datetime. So we will say df_pd square brackets equals pd.to_datetime brackets, and then which column we want to change, comma, and what format we want to change it to. In our case, you can see that it is American format, so we have months, date, and then year. And then we say a name of a new column. In our case, it will be month's name. So df_pd square brackets month_name, name of a new column, equals, then we say df_pd transaction date, because this is the column we work with, .dt .string format time brackets %b, and that will give you the name of your months. To display our dataset, we say df_pd. This line of code will print our dataset, so we can see how our dataset looks like with this new column. So let's run it. Okay, and now we have this month's name. You can see, for example, January, June. So we added this new column that has a name of a month. And let's do exactly the same, but with polars. So all these things will be one string in polars. When you convert in column to date time, and then you extracting this name of the month and creating a new column, it will be all one long line of code. So we say df_pl, name of our data frame, dot with columns, because we want to create a new column, bracket. In the brackets we say pl.column, brackets transaction date, dot string part time, bracket, then we say polars.date and the format, then dot dt dot string format time, brackets %b, exactly like we've done before, dot alias, brackets month's name. With dot alias we say how to name our new column, and then bracket just to close our bracket, and let's run it and see what we've got. And you can see that you've got exactly the same result as you've got with Pandas. So this command does a couple of things to create a new column. So at first we're selecting the date column, then we accessing the underlying date with dt and convert it to 3 characters month's name using string ftime. And then we name our new column as month's name using the alias functions. You will notice with polars, when you want to name a column, you need to use dot alias brackets, and in the brackets you indicate the name. Let's create a new column where we will calculate a transaction quantity as a percentage of all transaction quantities. And this way I just want to show you what capabilities polars have. In this case we say name of our data frame df_polars dot with columns, because we need to say with columns every time, brackets, then pl.column brackets transaction quantity, so we use our transaction quantity column, divided by pl.column transaction quantity sum, so sum of all the values within this column. Then we close our brackets, and then we say dot alias brackets percent total. So last bit dot alias to create a name for this new column. Let's run it. And now we have a new column, percent total. So it says that this transaction quantity, so this 2 out of all transactions is just this percent. When we created this new column, percent total, you might have noticed that the previous column which we created, which was months, is not there. So it doesn't exist here. When we created percent total column, we have only percent total column, and our month column disappeared. So that happened because none of the operations we've done are in place. So when you use withColumns method in Polars to create new column, it returns a new data frame with the added columns rather than modifying the original data frame in place. That's why you need to assign the results back to the original data frame or a variable to see the changes. In Python, equal sign is an assignment operator. So if you want to create a new column and we want it to stay, what we do, we say df_pl, so name of our original data frame equals, then we do everything we've done in the previous example, and let's see what we've got. Let's print it, and you can see that now our df_pl has this column percent total. If you want to make changes to original data frame, you need to assign it back to the original data frame. We say name of the data frame equals, and then the operations to create your new column. Let's filter our rows using str or string. Let's create a new column called category, and what we will do, we will check if the value in our column product category starts with C or not. By using .string, you can check if the value in specific column starts with specific characters. How to do it in Pandas? We will create a new column called category, so df_pd square brackets category, that's the syntax to create a new column, equals name of the original data frame, equals name of the original column, so df_pd, it's the name of a data frame, square brackets product category, that's the name of our column, dot string, dot starts with brackets, and then we can say what the value starts with. It will go through all the values and check if they start with C. So if they start with C, it will say true. If it doesn't start with C, it will say false. Let's print it. And here we are, we have a new column category which shows true and false. How to do it with Polars? We say df_pl dot with columns brackets pl dot call brackets product category, the name of our column, dot string dot starts with, and you can see here it has underscore, while in Pandas it doesn't have underscore. Starts underscore with brackets, then we say starts with C, dot alias category, and dot alias to give a name to our new column. Let's print it, and exactly the same results. We have a new column category which says true and false. Polars has a useful functions which is when, then, otherwise, which can replace Pandas mask or numpy.where. For example, we can see that in our product category we have value drinking chocolate, and I want to replace it with just chocolate. So my logic will be, if the value starts with the word drinking or drink, I want to replace it to chocolate, otherwise just keep the name we currently have. How to do it in Polars? So we say name of our data frame df_pl dot with columns brackets. So then we say Polars dot when brackets Polars column, we indicate the column where we looking for our values, dot string dot start with. That's why I used start with in the previous example, just to show you how it can be used. And starts with, and we say start with drink, you can obviously say drinking, you can say just D, but I wanted to make sure that it's applying for this drinking chocolate. So starts with drink, we close our brackets, dot then pl dot lit, so lit means literate, like literally, and then brackets chocolate. If our value starts with drink, we want to rename it to chocolate, otherwise brackets pl dot column product category. So if it starts with drink, we're renaming it to chocolate. If it doesn't start with drink, we just keep the value as it is, and dot alias category to give a name to our value. Let's run it, and here we have this category column, and you can see it says coffee, tea, and when it was drinking chocolate, it was renamed to chocolate. I personally really like this when, then, otherwise. It reminds me if, else, then, and I will show you how this could have been done in Pandas. To get the same result in pandas, we create a new column category, so df_pd brackets category equals numpy dot where brackets, in the brackets name of our column, or df_pd square brackets product category dot string dot start with brackets, here we say drink, comma chocolate. So if it starts with drink, we're replacing it with chocolate. Otherwise, comma, we keep the product category as it is. To display the data set, we say df_pd. Let's run it. And here we have exactly the same results. So you can see how it can be done in Polars and in Pandas. The next thing we will look at is grouping data. Pandas has group by as one word, and Polars has group_by. So it functions quite similar, but Polars doesn't have concept of index or multi-index. Let's group our data by store location and product category, and as values we will get transaction quantity, total transaction quantity for store location and product category. How to achieve it in Pandas? We say df_pd dot group by brackets, then in brackets we indicate the columns we are grouping by, so in square brackets we say store location and product category, and then we need to indicate values, so it will be total transaction quantity, that's why we say transaction quantity dot sum brackets, and we will reset our index. Let's run it, and that's the result. So you can see store location, product category, and total transaction quantity, and index was reset, so index starts with 0. And to achieve the same result in Polars, we say name of our data frame df_pl dot group by, you can see it's spelled slightly different with underscore, brackets, then name of columns, store location, product category dot agg for aggregate, brackets, pl dot column transaction quantity dot sum, because we want to total transaction quantity, dot alias again to create this new column, and the column will be total transactions. Let's run it. So you can see the difference. First of all, we don't have our index. As we've seen with Polars, we don't get index. We have this shape which shows how many rows, how many columns. Again, here we can see data types, and it didn't sort the values. So here we have all the stories. It was sorted in alphabetical order from smallest to largest based on our first column store location. In this case, that is not sorted by total transaction, not sorted by store location. We got exactly the same results, but without sorting. So the big change here is data doesn't have a multi-index. The result is roughly the same as using s_index equals false in Pandas group by. The benefit of this approach is it's easy to work with the data without flattening or resetting your data. But the downside of this is that you can't use unstack and stack to make data wider or narrower as needed. When you work with Pandas and Polars, there is a function to convert data frame from Pandas to Polars and from Polars to Pandas. For example, remember we were adding the column to rename our drinking chocolate into chocolate. At the end, if we add .to_pandas brackets, this way we will convert our data frame to Pandas data frame, and to convert Pandas to Polars we need to say from_pandas brackets. So after seeing what Polars can do, you might be wondering, why do you even need to learn Pandas anymore if Polars is so great and so fast? At the moment, Polars is not the best choice for data exploration or use with machine learning pipelines. And there are areas where Pandas continues to shine. At the moment, Polars is not compatible with most of Python data visualization packages or machine learning libraries like scikit-learn, PyTorch. The only exception is a Plotly that allows you to create visuals with Polars data frame directly. And probably solution is to use this from Pandas to Pandas. For example, you can analyze your data in Polars and then convert it to Pandas to create visuals. Another solution or advice is just to wait, because Polars is relatively new. There might be developed new interchange protocols where you change from Pandas to Polars and it will work with other libraries. In the description I left links to Polars documentation and to amazing resource I found. I don't want to butcher your name. I think it's Kevin Heavy. at GitHub. He compared Polars and Pandas, he has scripts, it's an amazing resource where you can learn more. I will definitely start using Polars more for bigger files I work with. I hope you found this video useful or learned something with me today. Let me know if you enjoy videos like this. Maybe I should do something similar. We can look through different libraries in Python together and learn them together, because when I'm creating those videos for you, I also learn something new because I go through documentation. If you enjoyed the video, don't forget to like and subscribe, and I hope to see you next time.